All right, now let's work through some examples of solving absolute value equations. So here we have -3 times the absolute value of x plus 1 equals -5. Now remember, we cannot distribute. We're not going to take that -3 and distribute it into the absolute value bars. Instead, what we're going to do is we're going to treat those this absolute value term kind of like its own thing. We're going to try and get it by itself. So if I were to get that by itself, the first thing I would do is subtract 1 from both sides of my equation. So that would leave me -3 times the absolute value of x plus 1 equals -5 minus 1 is -6. Now I'm going to divide both sides by -3. So I have -3 times absolute value. To undo division, to undo multiplication, I use division. -3 and -3 cancel, leaving me with x plus 1 absolute value equals -6 divided by -3 is +2. So now we've done the first step and we've isolated the absolute value. We have the absolute value of x plus 1 equals 2. Next, we're going to check to see if a solution exists. In other words, does this make sense? Absolute value is always positive. So I have positive equals positive. That makes sense. So this should have solutions. So I'm going to write two equations. Either the absolute value could be positive, meaning I could have what's inside the absolute value, x plus 1 equals +2. Or what's inside the absolute value bars, x plus 1, could be -2, because then when I take the absolute value, I'll get rid of that negative. Solving both of these, subtracting 1 from both sides, I get x equals 1. Subtracting 1 from both sides over here, I get x equals -3. Now, before we were checking our answers, that's always a good idea, but you absolutely don't have to do it. But if I plug in 1, I'll have 1 plus 1, which is 2. Absolute value of 2 is 2. If I plug in -3, I'll have -3 plus 1, which is -2. Absolute value of -2 is +2. All right, let's do another example. All right, so let's look at this example. We have the absolute value of 3x plus 2 minus 9 equals 10. So first thing we need to do is isolate the absolute value term. I'm going to add 9 to both sides. So I have 3x plus 2 absolute value is equal to 19. Okay?
I am Groot.
All right, now we've got the absolute value isolated, so we want to see if that makes sense. I have the absolute value, which always gives a positive, is equal to something positive. That makes sense. So I'm going to write two equations. Either what's inside the absolute value, 3x plus 2, is equal to 19, or what's inside the absolute value, 3x plus 2, is equal to -19. Okay? Now we're going to solve each one of these. Subtracting 2 from both sides gives me 3x equals 19 minus 2 is 17. Dividing both sides by 3 gives me x equals 17 thirds. So there's my first solution. Over here, I'm going to subtract 2 from both sides. So I'll have 3x equals -19 minus 2 is -21. Dividing both sides by 3, I get x equals -7. There's my second answer. So there's my two answers to this absolute value equation. All right, here's another example. So first step, always isolate that absolute value. I'm going to subtract 7 from both sides of the equation. We'll have 4 times the absolute value of 2x minus 1 is equal to 5 minus 7 is -2. I'm going to divide both sides by 4. We'll have absolute value of 2x minus 1 equals -2 over 4 is -1/2. Now, from here, we're going to get to the second step, which is check to see if a solution exists. So here we have the absolute value, which is always positive, equal to a negative number. Can something positive be equal to something negative? No. So that means we're done. We don't have to do more work. We know that the answer here is there is no answer, or no solution, or if you want to be fancy, the empty set. All right, so one more example. 1/2 times the absolute value of 3x minus 2 plus 1/4 equals 5. Now, the first step in general is to isolate the absolute value. However, because this problem has fractions, I would probably go ahead and multiply through by a common denominator to clear those fractions. If you don't want to do that, that's fine. You certainly don't have to. Okay? In this case, our common denominator between 4 and 2 would be 4. So I'm going to multiply both sides of this equation by 4. And see what happens. Well, first I have to multiply 4 by this term. 4 times 1/2 times 3x minus 2. Well, 4 times 1/2 is 2. So I'll have 2 times the absolute value of 3x minus 2. 4 times 1/4 is 1. On the other side, 5 times 4 is 20. Now we're going to isolate the absolute value. I'm going to subtract 1 from both sides, and I'll have 2 times the absolute value of 3x minus 2 equals 20 minus 1 is 19. And I'm going to divide both sides by 2 to get the absolute value of 3x minus 2 equals 19 halves. Okay. From here, I'm going to make sure that this equation makes sense. Absolute value is always positive, so I have a positive equals a positive. This should have solutions. So I'm going to write the 2 equations we need to solve. Either what's inside the absolute value, 3x minus 2, could be equal to positive 19 halves, or what's inside the absolute value, 3x minus 2, could be equal to negative 19 halves. Now I'm going to solve each of these equations and call it good. Okay, now from here, I have the option again of clearing the fractions, okay? So I'm going to go ahead and do that. I don't really want to work with the fractions. It doesn't matter. It's not terrible to work with the fractions. But I'm just going to multiply everything through by 2. If you don't like working with fractions, you can do that too. No, we'll probably still get a fraction in the end, but it'll be our very final step. So distributing this 2. 2 times 3x is 6x. 2 times negative 2 is negative 4. 19 over 2 times 2, the 2's cancel, and I'm left with 19. Now to solve this, I'm going to add 4 to both sides. So I have 6x equals 19 plus 4 is 23, and then divide by 6. So I get an answer of x equals 23 sixths. I'm going to take a minute and make sure that doesn't reduce. 23 and 6 don't share any terms, so there's one of my solutions. Now I have to solve the second equation. 3x minus 2 equals negative 19 halves. Again, I would probably multiply both sides of this by 2. 2 times 3x is 6x. 2 times negative 2 is negative 4. Negative 19 halves times 2, the 2's cancel, and I'm left with negative 19. Now I'm going to add 4 to both sides. So I get 6x equals negative 19 plus 4, which is negative 15. Dividing both sides by 6, I'm going to move this up here. Gives me x equals negative 15 sixths. But I'm pretty sure that will reduce. Both 15 and 6 are divisible by 3, so I'm going to divide top and bottom by 3 to get negative 5 halves. So there's our second solution, negative 5 halves.